Okay, so I'm making this video due to public demand. Okay, so lecture chapter 7, chromatography. No? So as you can see, no, probably na-discuss na sa inyo, that chromatography is one of the uh, analytical separation technique used in the laboratory to separate compounds based on different parameters such as the size, the charges, and most importantly, the polarity, or most commonly, the polarity. Okay? So, as discussed in your lecture, so medyo pahapyaw na lang gagawin ko. Just to emphasize lang yung critical info that you might have in mind. So that's why you're asking for this video. So, yan, diniscuss ni teacher niya yung means to separate the mixture. So there are many ways we can separate them based on the particle size and the molecular properties. Yeah. So for particle size, so madali lang, you either filter them or decant them. But in doing separation by molecular properties, so medyo maraming paraan na. So you can do distillation, evaporation based on the boiling point or the strength of intermolecular forces. You can use chromatography to separate them by size, by charge, or by polarity, and then liquid-liquid extraction to separate polar and non-polar compounds. No? So yun nga, filtration works by separating the components of a mixture based on their particle size. No? So probably ginawa nyo na ito nung high school. No? So you have your filter paper, you have this mixture containing big particles and aqueous system, liquids. No? So you pour it here, yung liquid tumutulo dito sa dulo. So they are called your filtrate, and then yung collected na solids, they are the residue. No? One of the common means of doing filtration in the context of COVID-19 pandemic is this, the face mask. No? So your face mask is actually 3-ply, meaning tatlong layers yan. So each layer serves a purpose. For example, yung unang layer, I think that is for the initial blocking of big particles, no? Such as yung mga pollutants. No? The inner layer is the one that can trap electrostatically charged particles. No? And then yung last layer dito is your absorbent layer na sa mga laway-laway niyo, ina-absorb niya. Kaya namamasa yung loob ng face mask natin. No? So yeah. So as the particle passes through the face mask, no? Ano siya? Nafi-filter lang yung very tiny particles that can enter, no? So it's effective against viruses, no? It can help separate you from the viruses around you. Okay? Probably dito sa electrostatic portion, no? Okay? So may charges kasi yung mga viral protein. So na-trap sila probably here, no? So yun. And then yung laway-laway nyo, hindi na siya tumatalsik kung saan kasi it's absorbed by the cotton filter inside, no? Yung white layer ng face mask. Okay? So yan. Another example of filtration that's used in the clinical setting is the dialysis setup. No? So in the dialysis setup, what happens here is yung blood mo, it's dirty. It's a combination of all the dirt inside your cell that gets released by the cell. And actually, your kidney does the work dapat, no? So your kidney cleans your blood by removing the toxins from your blood. For example, ano ba yung mga toxins na nandun? The urea, okay, and the water, excess water in it. So yun. But if your kidney fails, then you have no other choice but to undergo dialysis now. So ganyan yung nangyari sa dialysis, no? Because the kidney fails, the dialysis machine does the work. No? So in a dialysis machine, there are several layers here. There are several membranes. in which bigger particles such as hemoglobin and some water molecules, proteins, won't be able to pass through except for the dirt, no? Such as those toxins, no? Such as mga urea, okay? Phosphates, chlorides, etc. Okay, so they all get passed through except your big molecules. So in a way, parang kidney nga siya. Okay, but medyo malungkot kapag nag-dialysis ka na, no? Kasi mahirap. You really have to go to dialysis machine every now and then just to have yourself clean. Because otherwise, if the dirt accumulates, then it could have a detrimental effect to your body organs. No? So pros of filtration, it's simple. The range of particles that can be filtered is wide, no? From big particles like sand using a filter paper to molecules inside your cell using hemodialysis now. So malawak siya, or even viruses as prevented by your face mask. Ang cons lang is it takes very long time, no? For example, di ba nag-filtration kayo ng precipitate ng experiment number 3 sa gravimetry? Tagal, di ba? So yun, matagal siya. Especially kung hemodialysis yan. How much blood you have inside you. Magpapass through lahat sila sa machine. So it will take very much time. It will take a very long time, no? Just to clean everything. And it's not effective when your sample, okay, when your analyte you want to remove from the mixture is dissolved, no? For example, it's ethanol and water. You cannot filter paper it, no? Kasi ethanol and water are interacting with each other, no? Okay, so hindi mo siya ma-filter paper na. Okay? Ayan. And next one, we have the decantation. So in the decantation, you have your sediment or the precipitate. Hayaan mo lang siya mag-sink sa bottom and then you remove the top layer, okay, by slowly slanting it, no? Okay? And you should get clear water and then yung sediment nasa ilalim na. So I think ginawa nyo, no? Gravimetry, no? Okay. So by properties of compounds naman, well, we have physical property and chemical property. So pag physical property is about boiling point and density lang, okay, such as in distillation and evaporation setup. So we make use of the boiling point of compounds. For example, ito, simple distillation setup. If you want to remove salt from water, you use a distillation setup or evaporation setup. Such as yung salt farm sa Pangasinan. If you're from Pangasinan, probably alam nyo may salt farm doon. So in salt farm, sa beach, ina-expose yung seawater sa sunlight so that the water will evaporate, leaving behind salt. No? And we also have this thing called the fractional distillation or oil refinery. So you have your crude oil, which is a combination of many hydrocarbons. But based on the boiling point, you can separate them from low carbon molecules to high carbon molecules. Flotation, we use this for compounds or materials that differ in density. For example, plastics float in water. So you can just let them float, no? And then you just filter the surface waters. No? So this technique is used in microplastic studies. No? So yung mga microplastics, those are plastics that end up in environment. And then those plastics were degraded by ultraviolet light or the mechanical shearing due to the rigorous pathways it has to undergo from soil to water, or just the friction that's generated by splashing water in the ocean. No? So lumilit yung particles. So you can let them float. No? Ang ginagawa dito sa flotation is that we utilize the density of the particles let's say salt water yan and plastics, of course, plastics will float, no? But if you increase the salt in this salt water, lalagyan mo ng mas maraming asin, then mas lalong lalaki yung density changes niya. So more and more plastics will go up sa surface. Okay, so this is actually one of the emerging problems we face as humanity. Now, so apparently microplastics can now be detected in brain fluids, in the mammary glands ng magulang natin. So, ganun siya ka-dangerous. We don't know the extent of the dangers it imposes, but we know it's a threat to us. We also have liquid-liquid extraction. No? Suppose you created a chemical reaction and dissolve siya sa liquid. If you want to remove that compound in a liquid, you do liquid-liquid extraction. So in a liquid-liquid extraction, you have your aqueous and organic phases. No? Aqueous meaning water. Organic means any organic or non-polar compounds. No? Suppose you want to create caffeine. Okay, so caffeine dissolves in water. Okay, but you can isolate it well with organic solvents, no? Such as chloroform, for example, or dichloromethane. So in a separatory funnel, shown in the picture, ginagawa dyan, sinishake-shake yan until yung compound that you want to remove gets trapped, no? In a layer of aqueous or organic layer, no? So ganun lang. And finally, the focus of this topic is the chromatography. No? So medyo historical context tayo. So chromatography, no, is a method of separating mixtures of compounds based on the physical or chemical properties. When you say physical, that could be the polarity of the compound. No? Chemical, it could be the electrical charge. No? Okay, or the molecular size. No? For physical again. Okay, and it was actually invented by a Russian botanist called Mikhail Spet, no, in 1835, in which he won the Nobel Prize, no, in 1952. Sorry, si Martin and Singe pala yung nanalo ng Nobel Prize, no, in developing the paper chromatography. But si Mikhail Spet yung pinaka-unang naka-discover na pwede pala yun. Okay. And then later that year, na-develop yung gas chromatography. And then eventually na-develop yung high-performance liquid chromatography. Okay? So what's the guiding principle in chromatography? So in chromatography, you can separate compounds based on their polarities, okay? And affinity toward the mobile phase and the stationary phase. No? When you say mobile phase, ito yung gumagalaw, no? Which is the liquid or the gas, no? In which your sample will be carried across the stationary phase, which is your column. Okay, so a stationary phase is a column or solid or liquid material that interacts with your sample. Dilution is the time when your analyte passes through the stationary phase, if it passes through the column. So we have many types of chromatography. First, we have the thin layer chromatography. This is what you did in experiment number 9. So in thin layer chromatography, you separate the compounds based on their polarities. No? Okay. So as you can see here, let's say you have a paper which is polar because of the hydroxyl groups of your of your cellulose. Then yung salt water mo dito or alcohol, which is lesser polar than the paper, it will soak your sample, and then as the liquid rises via capillary action, the components of this mixture separates. Dami kong ana. They separate based on their attraction towards the stationary phase. One can think of it this way. Okay, para madali isipin, ganito. Isipin niyo may building na ito dagat na. So ito may building ka. Tapos dito may puno ka. And then you have a trash can. Then isipin mo may alon. Alon yan ha. Okay. Kunwari tsunami. Kapag may tsunami yan, so isipin mo lahat sila nandito sa spot na to. Pag may tsunami, iba-iba yung distance na ita-travel niyan, di ba? Depending on how well or how fixed they are to the soil. Yung soil natin is our stationary phase, no? And our building, puno, trash can are your solutes, no? In the mixture. Yung alon is your mobile phase. Ngayon, kapag yung alon tumama sa lupa, sa stationary phase, what will happen? Dadaloy siya pag ganun, di ba? Now, depending on how attracted the building, the tree, and the trash bin are to the stationary phase, they will travel different distances. For instance, yung trash bin, hindi siya fixed sa ground, so it will travel the farthest distance. No? So, kapag less yung attraction niya sa stationary phase, malayo mararating niya. No? Okay? Malayo na travel niya. So, from here, napunta siya dito. Okay? So, we can say this is the farthest. Yung puno, yes, it's fixed to the ground, pero if malakas yung alon, then matatangay siya. No? Pero yung building, malalim yung foundation niyan. So meaning it's very attracted to the stationary phase. So hindi gagalaw yan. Okay? So in a way, we can think of it this way. So the paper is polar. Okay? So meaning, those compounds that travel furthest are less attracted to the polar, or meaning they are less polar molecules. So parang sila yung trash can. Hindi sila attracted sa stationary phase. They are not attached to it. Therefore, they will travel the farthest distance. On the other hand, compounds that are fixed to the stationary phase will travel a short distance lang. For example, yung puno, medyo onti lang distance. Pero yung building, di gagalaw yan. So it will stay there. Probably. So the shorter the distance traveled from the origin means the more polar it is, no, in terms of thin layer chromatography. And the farther distance it travels, the lesser polar it is. No? So depending on the distance traveled by your solute, no, from the origin, so this is your origin, kung saan ka nag-spot, no, we can compute for the retention factor. Okay, so the retention factor is a ratio of the distance traveled by the solute over the distance traveled by the solvent. Okay, so how does the TLC work? So you have a stationary phase, you have paper silica, which is polar, and a mobile phase, which is lesser polar, such as alcohol-water mixture or acetone. So yan, RF value is the solute distance from the origin over the solvent front, or the distance traveled by the solvent. No? So, ang idea lang is that if it has a higher RF value and it has higher affinity to the mobile phase or lesser affinity to the stationary phase. Na? If your stationary phase is polar, okay, kung stationary phase mo ay polar, tapos mataas RF value niya, ibig sabihin, hindi siya attracted sa polar. Therefore, you can conclude it's less polar or non-polar at all. Okay? So typically, higher RF means the molecule is less polar. Lower RF means the molecule is highly polar. For instance, dito, nagawa nyo to sa lecture. So di ko na siya i-compute ha. So for instance, this blue spot here traveled less distance than the pink one. Ibig sabihin, blue is the most polar among the three. And this one is the least polar. Okay? Because it traveled a very long distance. No, sige, compute tayo. If you want to get their RF value, so again, remember, RF is the solute distance over the solvent front, no? Or the distance traveled by the solvent. So we can put numbers here sa ticks. So say the solvent can traveled 4 centimeter. This one traveled 1 centimeter. So 1/4 is 0.25. Then yung RF niya. This one, it traveled 2 centimeter. So it's 2/4 or 0.5 yung RF niya. This one traveled 3 centimeter. Yung solvent, 4 centimeter. 3/4 is 0.75 RF. Okay? So the higher the RF, the lesser polarity it is. Now, we can improve the thin layer chromatography. So usually thin layer chromatography is the preliminary step in chromatographic analysis. No? Kasi you want to determine what solvent is best for that type of analysis. No? So pag nalaman mo na what solvent is best in separating the mixture in your sample, then you proceed with the liquid chromatography. So it works in a similar fashion wherein depending on how attracted your analyte is to the stationary phase, ano siya, yung distance na ito travel niya, maliit lang. No? While if your analyte is less attracted to the stationary phase, then it will travel the farthest. So mabilis siya lalabas. For instance, okay, yung kulay blue dito, as you can see, maigsi lang yung tinatravel niyang distance na. So maigsi lang yung distance na tinatravel niya. Ibig sabihin, malakas yung kapit niya sa stationary phase. On the other hand, yung red band dito, weak yung interaction niya with the stationary phase. So therefore, mabilis siya mag-travel. Na? Mabilis siya lalabas. Okay? So tawag sa paglabas ng compound mo sa column, we call that the elution. And yung tawag sa lumabas ay eluent. No? Eluted molecules. Okay? So yan, ito lang yung idea. So the higher affinity to the stationary phase, the longer the elution time. So mas matagal sila mag-interact. And then pag lower affinity to the stationary phase, mas shorter yung elution time. You can think of it this way. No? Kunwari nasa kantin ka. Kung hindi mo kakilala yung tao, isipin mo yung isang tao ay stationary phase. Pag di mo siya kilala, dadaanan mo lang siya. Eh di mabilis ka makakalayo sa kanya. Pero kung kilala mo yung tao doon, eh di tatambay ka pa. No? Magdadaldalan pa kayo bago ka umalis. So ganun lang. Parang ang idea is kung hindi mo kilala yung tao, you're not attracted to that person, mabilis ka makakalabas ng column. Okay? So yung red dito, hindi niya kilala yung stationary phase. So dire-diretso lang siya palabas. No? On the other hand, yung blue, best friend niya yung stationary phase. No? So tagal nila mag-usap. So kaya ang tagal niya makalabas. No? Parang ganun lang. Chismis lang. Chismis lang ang ginagawa nila. Okay? So that's the logic. Now, there are two types of chromatography. We have the normal phase and the reverse phase now. In a normal phase chromatography, your stationary phase is polar. For example, silica. So silica is SiO2, which is a polar compound. Okay. Ibig sabihin nun, if you have a polar analyte and then polar yung stationary phase mo, so matagal siya lalabas as shown here in the in this GIF. So this is your silica, SiO2. And yung polar, since besties sila, para sila polar, tagal siya lalabas kasi yung chichikahan pa sila. Yung non-polar, wala yung pake. I don't know you, so una na ako. Ganun. So mobile phase is non-polar, stationary phase is polar for a normal phase chromatography. On the other hand, we have the reverse phase chromatography. So sa reverse phase chromatography naman, still have a silica pero it's functionalized to have a non-polar tail, such as the silica C18 column. So because of the non-polar tail, yung non-polar ngayon yung mag-interact sa stationary phase, C18. Nagdadala naman sila, non-polar to, non-polar ako, usap tayo. Under the polar, I don't know hindi niya kilala yung C18. So, dire-diretso lang siya lalabas. Okay. So, ganun lang. So, that's the difference between normal phase and reverse phase. Pag normal phase, stationary phase is polar. Mobile phase is non-polar. Pag reverse phase, balik na rin mo lang. Stationary phase is non-polar, such as in C18. The mobile phase is polar, such as water. Ito yung downside with the column chromatography. Ito, tagal niyan, super. Nung ginawa namin yun nung college, sinabot kami halos 1 oras lang para lumabas yung compound na. Tagal, super. Pero, siyempre, kung nasa laboratory ka, tapos matagal yan, edi ubos oras, di ba? Sayang hindi tayo efficient pag gano'n, no? So, ginagawa namin mga chemists is we use this one called the high performance liquid chromatography. Okay? So, HPLC. Ito yung ginagamit ko sa Ateneo. HPLC dito is like column chromatography but faster. Okay? Kasi may pump dito sa ilalim. So, ginagawa niya, instead of the gravity pulling your liquid, pinupush na niya yung analyte mo sa column. Pinupush na niya para, lumabas na kayo, ang tagal niyo. No? Parang uwian lang yun, tapos yung guard pit, tinutulak na kayo palabas. No? So, ganun. May pump siya so that the elution of the analyte here is faster. No? So, ganito yung ginagamit ko sa Ateneo. So, in HPLC, yan siya. So, you have your pump here. These are your sample carousel. This is the column now. No? So, yung column. So, ito yung C18. Usually, mahaba yan. And then, as the compound passes through the C18, lalabas yan dito, it will be detected by a detector. So, maraming detector. Meron tayong RID detector or refractive index detector for non-colored compound. And pwede rin UV-Vis for colored compound. No? Okay. Ayan. So, ayun, HPLC chromatogram, yun yung graph na nade-develop in which yung analyte mo lumalabas over a period of time. No? So, nasa x-axis niyan ay time. And yung nasa y-axis is yung absorbance or something else. No? So, nangyari sa chromatogram, depending on the time, doon lalabas yung compound mo. Okay. So, kunwari may lumabas na compound dito, may lumabas na compound doon. So, ibig sabihin, may dalawang components ka sa mixture. No? Now, how will we interpret the time? Well, nag-a-apply pa rin yung sinabi ko kanina. No? The longer the time it takes to get eluted means the more attracted it is to the stationary phase. Pero the faster it gets eluted out, ibig sabihin, the lower its attraction to the stationary phase. No? Now, the polarity of the eluted compounds depend on what type of chromatography you're doing. That's a normal or a reverse phase. No? So let's say you have a normal chromatography, normal phase chromatography. Ano yung stationary doon? Polar, di ba? So you can think na yung unang lumabas, kung polar ang stationary phase, yung unang lumabas ay non-polar. Yung lumabas sa dulo ay polar. Okay? Bakit nasa dulo yung polar? Kasi ang tagal nila mag-usap ng polar stationary phase. So, na-stuck siya, na-traffic siya. Pero yung non-polar, hindi naman niya kakilala yung stationary phase. So, lumabas na siya agad. No? Now, how about if yan ay reverse? No? Kapag yan ay reverse, baliktarin mo lang yan. So, unang lalabas yung polar, dulo lalabas yung non-polar. Bakit? Kasi non-polar yung stationary phase, no? Yung C18. So, si polar, di niya kilala yung C18 non-polar kasi. So, lumabas na siya. Pero yung non-polar, attracted siya sa polar. Sa non-polar stationary phase. So, ang tagal nila nag-usap. No? So, matagal siya nakalabas. Okay? So, let's look at this graph. No? This chromatography. Sabi dito, you're given a chromatogram of a reverse phase chromatography. Which of the following compounds is the most and the least polar. So alam natin kapag reverse phase, stationary phase is non-polar. Ibig sabihin yung nasa dulo, ito yung mga non-polar. Yung mga nasa harap, ito yung mga polar. So if we rank them by increasing polarity, okay, so I'll label this as A, B, C, D, E. If we rank them by increasing polarity, so it will be E followed by D followed by C followed by B followed by A. Increasing polarity, so from non-polar to polar. No? Ganun. So meaning, the most polar is the ampicillin and the least polar is the diclofenac. Okay, so ganun lang. Now, what if this is a normal phase? No? Kunwari normal naman yan. Eh di baliktarin mo lang yung trend. No? So ito yung mga non-polar na nun. Ito na magiging polar. That is if ito ay normal. No? Baliktarin mo naman yan. Okay? Okay, for this one, kunwari you're assigned this chromatogram. Alam natin, these are hydrocarbons, no? These are benzene derivatives. So ngayon, in a nonpolar compound, which is the most dominant force of attraction, it's London forces, no? And alam natin sa last sem nyo, that the higher the London force, the higher non-polarity of the compound, no? Another thing is that the London forces increases by the number of atoms, no? So the more atoms you have, the higher the London dispersion forces. That's why methanol is polar, okay? CH4O, and oils sa mantika, which is still organic compound, is non-polar kasi 18 carbons yan usually. Okay. So yan. So the more carbon atoms, the more non-polar. So ganun gagawin natin guiding principle here. The more carbon atoms, the more non-polar. So let's count the carbon atom here. 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 carbons. This one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Tama ba? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Dito, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So ito, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. So yan. So we have 8 carbons here, 12 carbons here, 14 carbons here, and 10 carbons here. The idea is that the greater number of carbons, the more non-polar it is. No? Reverse space to eh. Sabi-sabihin yung mga polar nasa dulo. Yung mga non-polar, baliktad. Yung polar nandito sa harap, no? Yung non-polar nasa dulo. Okay? Kasi reverse phase, no? Ang stationary phase ay non-polar. So matagal lalabas yung non-polar kasi magdadaldalan pa sila. Pero yung polar lalabas agad yan. Hindi niya kilala yung non-polar na stationary phase. So paano natin i-rank to? So kung i-rank natin to, well, ang mauuna yung C8, no? Followed by C10, C12, and C14. So again, the idea, the more carbon you have, the greater the non-polarity. Yeah. So although lahat sila non-polar, we can say na yung ethyl benzene is a bit more polar than the phenanthrene. Ayan. Now, kunwari, hindi naman ganyan. No? What if kunwari may ka? Teka lang. I'll pause the video. I'll make one example pa. Okay, so let's have this for example. Okay, so suppose this is a reverse phase chromatography, the illusion of compounds are shown as written here in the chromatogram. Okay. So makikita mo that the methanol appears in front and the propan-1-ol or the 1-propanol is at the end. No? So let us try to think of that. No? Okay, ngayon naman may mga ano na tayo, functional groups na. So ito-drawing ko yung ibang compounds. So for methanol, it's CH3OH. So I'll just pick some of the for ethanol, it's CH3CH2OH. And for the 1-propanol, it's CH3CH2CH2OH. So again, let's say this is the reverse phase chromatography. So meaning your stationary phase is non-polar. Okay. So the idea, if you have a non-polar stationary phase or reverse phase chromatography, yung mga nasa left side is are polar. And going to the right, it's becoming less polar or non-polar at all. Okay. So let's analyze. So between methanol and ethanol, so there's an increase in carbon group. And as I said earlier, now when you increase the carbon groups, ano nangyayari? Di lumalaki yung non-polarity niya. Okay? And then add another carbon group, propanol na, tatlo na yung carbons. So indeed, mas malaki yung non-polar side niya kasi sa polar OH. So this molecule is less polar than ethanol, and ethanol is less polar than methanol. Now, okay, so let's visualize other functional groups included here, such as acetaldehyde. Okay, and acetone, and then propanol, propan-2-ol. Okay. Okay. So now, tignan natin yung methanol to acetaldehyde. So methanol and acetaldehyde, well, acetaldehyde will be less polar than methanol for the primary reason that methyl group nadagdagan na. Dalawa carbon dito isa lang. So more London forces, right? But now let's compare acetaldehyde with the 2-propanol. Okay. So if we compare it to 2-propanol, anong nagpe-play ng role dito? The symmetry of the compound. Biglang may ganun na. If the compound is symmetrical, such as in propan-2-ol, then it tends na weaker yung dipole moment niya. Look at the 2-propanol. You can cut it in the middle. On the other hand, the acetaldehyde is not symmetrical. So meaning it has greater dipole moment or it is more polar than the 2-propanol. Okay? So lesser polar yung 2-propanol than acetaldehyde because of 2-propanol's symmetry. Okay? So lesser yung dipole moment. Unlike ito, hindi siya symmetrical. So mas polar yan. Okay? Greater yung dipole moment dyan. Now, let's compare these two functional groups. You have your carbonyl, or you have your ketone, and your alcohol. So why is the ketone or acetone less polar than the OH? Okay, well, alam natin OH is one of the most polar bonds. Okay, so acetone is just dipole-dipole. Alcohol, on the other hand, is hydrogen bonding. So this is less polar than this one. Okay, so those are the things you have to consider. The symmetry of the molecule, the number of the polar groups, and the relative rank of your polar molecules. Okay. Okay. The next one, we have the gas chromatography. So in TLC, LC, and HPLC, may mga liquid doon. So liquid yung mga mobile phase. But in the gas chromatography, you have gas as your mobile phase. So your gas will carry your sample across the column. Ganito yan. So you have your GC, and then you have a tank here, which is sometimes nitrogen gas or helium. You cannot use hydrogen gas because it will explode. Sabog yan. Okay. Yeah. So it's either helium or nitrogen gas. Okay. Because those are inert compounds. Well, helium is more expensive. So ginagamit is nitrogen gas. Okay, so may ganito sa Ateneo, pero di ko pa siya natatry. No? So what happens here is that may stationary phase ka pa rin. Iba-iba yung polarity ng stationary phase this time. And then yung gas mo is just inert. Tutulak lang niya lahat to pass across the column. And then in gas chromatography, it is usually tandemed with FID, flame ionization detector, TCD, thermal conductivity detector, and mass spectrometer, or MS. Ang common ay GCMS, gas chromatography, mass spectrometer. Okay? So as you can see here, nakuha ko lang to sa kung ano man brand to. So iba-iba yung column na ginagamit. Sometimes they have a very non-polar, a column designed for non-polar analytes and a column for polar analytes. So depende talaga yung stationary phase. So hindi siya katulad ng HPLC na may reverse, may normal. No? So ganun. So saan ina-apply yung chromatography? Well, sa lahat. No? So actually, this is the bare minimum. If you're a chemist, dapat marunong ka mag-chromatography. Kasi kung hindi, edi magta-training ka. But yeah, knowledge of chromatography is a very huge advantage in the industry. You can use it for drug discovery. No? So, for example, this one, okay, pwede mo malaman kung nagda-drugs yung tao. Or you can actually determine how drugs work in a cell, in a cellular level, etc. How to make new compounds of gas, of drugs, etc. In food and beverage, chromatography is used to determine if there are contaminants. Ito yung ginamit para malaman dun yung lambanog issue. Alam niyo yan. Diba dapat yung nasa alcoholic beverage ay ethanol pero may methanol na na-detect. No? Paano nila na-detect yun? HPLC. Okay. So yan, it's used in quality assurance for food, quality control. For forensics naman, so ito na yung mga drug testing na yan. Okay. So may mga chemists sa mga drug testing facilities. So kasi kami may alam kung paano gumamit ng chromatography. Ang ginagamit dito is GCMS. Meron din naman ata LCMS such as this one. Okay? Pero common yung GCMS. So yung nangyari dito, yung sample, binavolatilize siya. If it contains a volatile component, then pinipair yan with, let's say, if that is GCMS, you tandem it with mass spectrometry. Pwede rin naman yung liquid chromatography sa mass spectrometry. No? As you can see here, iba-iba yung elution time ng iba't ibang drugs. No? So meaning, if may makita kang drugs dito that appears at this time, sabihin positive ka. No? Pare, yan yung chromatogram ng dugo mo. So biglang may pick ka dun. So it means addict ka. So ganun nangyayari in drug testing. So ano yan? This is well established. No? It's a very reliable test. No? In environment, gas chromatography is used in detection of PFAS, okay? Polyfluorinated alkyl substances, forever chemicals. Saan nakikita yung forever chemicals na yan? Nasa Teflon. Yung mga Teflon, kapag yan ay na bakbak, that PFAS may actually enter your body. And due to its resemblance to the natural lipids in your body, it may replace your lipids, no? And can cause cancer. Ayan. So well, it is an emerging field in environmental chem. Yung chairperson sa Ateneo, Dr. Ian Kendimson, is a lead scientist in PFAS studies in Ateneo. Very very new field na and a lot of potential for future research. Okay, so that's it pala. No? So yun lang. So ayun, again, the goal of this video is just to be a supplemental discussion dun sa tinuro sa inyo sa lecture. But in case you have question, you can always chat me naman. Okay? So I hope you refresh your knowledge. No? So see you next time. Bye-bye.